So again, aggregation as containment by reference can be displayed the same way we discussed it over here. So we say right here that the interpretation of this diagram is the department is made up of employees. And it also means that certain essential employees have to be constructed at the same time as the department organizational structure is constructed in memory. So syntactically, aggregation in Java, in C++ can be compared like this. So they look very, very similar to simple association. It's really the code that creates employees and departments has to be written with respect to the idea that we have this aggregation relationship between the two concepts. So composition is containment. Like we said, that if we have a certain device and it has the controller, or like we have automated teller machine at the bank, it has a cash dispenser. So there is physical containment, and this is how it's indicated right here. So this is the whole and this is the part. So multiplicity and encapsulation can both be used with aggregation and composition, and encapsulation, of course, is also can be used uniformly in our UML diagrams. There is really not much restriction between all of these parts of UML design indicators that we can put in place in our diagramming in our design. So these are examples, like we have this aggregation indicator right here. This is the whole and this is the part, and we say that the catalog can be empty, but the catalog basically is almost like unusable without the presence of books in them. And so the book becomes an item. The role of the book in the catalog is a catalog item. Okay, and of course this indicates the multiplicity. And remember, something like this can be, instead of saying 0 to many, we can just use a single asterisk in place of this entire thing, right? So this entire thing can be replaced by a single asterisk, and it indicates 0 to many. So we can have 0 books, or we can have a lot of books. Because Java in general uses object references and not actual copies of objects, all object copies are created by Java Virtual Machine, and all physical memory is managed by physical machine. We really don't have much facilities in Java to implement composition. Composition is mostly a part of the design when you deal with C++, because in C++ it's very possible to construct objects from other objects. Other type of relationship in UML is indication of an inheritance. Like we said in the example of our airline reservation system, it would be possible that we have an aircraft type object in the system, but here we could have different types of aircraft. For instance, we can have a cargo aircraft and the passenger aircraft, and we can then indicate this type of relationship, inheritance, also known in UML as generalization relationship, like this. Okay, so that these arrows are pointing towards the top of the hierarchy right here. So we say that cargo plane is an aircraft, and passenger plane is also an aircraft. So this is very important type of relationship, and the description here may be, or validation for inheritance may be like this. These are components, examples of components of user interface. So we have a button, which is a graphical user interface component, and we have a panel, which is like a container for other gadgets on the user screen, which is also a kind of component. So why this recognition of button being a component and panel being component is recognized? Because both of them very likely are having some kind of rectangular shape or something close to the rectangular shape. So that rectangular shape would require position of the top left corner and then width and height of that rectangle. Likewise, panel would have to have X and Y and W and H. And when we resize button and panel, that resize method or operation in both probably manipulates these things in a very, very similar type of calculation, right? Recalculating position X and Y, recalculating width and height, adjusting what's being displayed by the button and what's being displayed by the panel if our button and panel somehow become resizable. So you see that this is something that almost like copy and paste situation. So when we have this copy and paste situation that we are facing when designing our classes, then we immediately should recognize a commonality, right? So this is where inheritance comes to help, and we can just then say we are not going to use X, Y, W, and H at the level of button and panel. Instead, we are making it a universal component in user interface, and it will have X and Y and width and height values right here, and we can have then have it resized and so forth, whatever we need to do with these things. Resize, move operation, resize, move. There could be other operations that could be defined on based on these values. And so resizing and moving a button will be exactly the same as resizing and moving any other component, including the panel. So this is why we have this inheritance. Now this is the design time. So at design time, we create class name component, and we create class name button, and we create a class name panel, and we write these concepts individually in each class. However, at runtime, it's very likely that when we run the system, when the button is created, it will be an object in computer memory, okay, and it will physically contain the component instance. So it's normally a physical containment, so that basically these two will be combined together at runtime. So as soon as we create the button, because button is inheriting everything from the component, we say that button is also a component. So at runtime it materializes into this containment that the button right here, right, so this is the bigger box is the button, contains the component inside of it, because it needs all of the properties and operations that component has. So this is the inheritance that happens in real computer memory, that basically the button will own and contain an instance of component in its own physical memory. Same thing with the panel. If we create the panel box, it will contain this very similar type of a component instance inside of it, like this. And so this will be the component right here, and this will be the panel, right? So this is the panel class, and this is the component class. So both button and panel will have component inside of them when we create an object of this type and of this type.